NLP and cloud management, and several of those small units we are teaching. Plus, we'll assign people of projects, career building, and we will also match people with the recruiters. So those started, we are planning to launch in June, but the application has started. There will be several different options, including income sharing agreement. Today I will talk about, we have a speaker, Ioana Cozmuta. She's a TEDx speaker. She has a similar background with me. That I come from biophysics. I come from physics background. Then I later became a biophysicist. Now I'm doing cancer diagnostic at Stanford.
Oh, interesting.
It's a big transition. I'm in medicine. So, but we do work with data still.
Okay, that's important, I guess.
So it's hard to avoid data. So I'm telling people the data science skills, it will be like a driving skills.
It will.
So everyone has to have such skills. Like at least you should be able to pull the data and some simple analysis and make a judgment on anything. So she's managing partner of Gravity Free Consulting. Is it free consulting or gravity free consulting? It's not free consulting.
You see, I'm not responsible for how people want to understand that or take that. So.
And the CEO of G-Space, a woman-owned business. And these two portfolio companies are showing her actually all expertise to discover new revenue opportunities for non-aerospace and industry sectors and help accelerate their time to market. This is really interesting topic to hear about. This different new market.
I hope to provide.
And second is to develop and design and optimize advanced and new materials by liberating potential design space from the limiting effects of gravity. That's also a really interesting challenge topic for us. And her work at the confluence of space and Earth is based on a 19 years career in startup world at NASA and academia, and combining expertise in physics, computational chemistry, and material research. And she holds a PhD degree in applied physics from University of Groningen, and postdoctoral degree in Caltech and Stanford from UD Genomics and biotechnology as well.
That's good.
So everyone will have to learn biology at one point, I guess.
I guess. Well, not necessarily. It depends. There's many fields, but it's a driver.
It's a good one. Yeah. She's a visionary thought leader and futurist, frequently invited as a speaker, including TEDx, at a national and international level, events related to new space, market entry opportunities, microgravity, and space technology. Let's welcome her. It's a great opportunity for us.
Thank you. Thanks for the intro. Thank you for being here tonight. I guess. Is this working? Is the microphone working? Can. Oh, okay. I see. It goes over there. Okay, perfect. Sounds good. So, first of all, I'd like to ask you, how many of you are familiar with what's going on in commercial space, or have worked in commercial space, or just passionate about space? None of you? Marginally. Outer space, new space. Yes, that's what I mean. Yeah, space technologies, space exploration. Okay, so that's interesting. So how many of you are data scientists? 2. Okay. How many of you are in management positions?
Used to be.
Okay. How many of you are in engineering? That gives me a good, okay. How many of you are in sales or marketing? Great. And how many of you are undefined? Because I'm missing some. Okay, great. Okay. So I'll try to do a mix, and I did put, because I didn't know exactly the composition, but I also know that in general the trend here is more on the data science. So I tried to put a little bit of a data science flavor onto the charts, and what I would try to highlight is a little bit of data science opportunities at this intersection of what's going on in new space. And when I talk about new space, I'll explain that here in a little bit. Is literally we're seeing this shift from government-driven investments in space exploration to commercial. So I'll provide a little bit of a background in that. So actually, my first topic is the new space landscape, a little bit about the global space economy, government versus private sector drivers. So I worked for NASA for 18 years, from projects, engineering, like Mars Science Laboratory, Stardust, and Orion, to space technology commercialization, International Space Station commercialization, and driving this new space economy, and how the shift again from the investments has driven the new space value chain that we see forming now, and also where it is right now, because we're in Silicon Valley, and of course everybody knows about. Okay, do you want to have? Okay, I'll approve you temporarily. Okay. That's gonna open a window. Okay. I guess I have to give you permission here. No. Okay.
Oh, it's
It's working.
working.
Okay, good. So yeah, what are the couple of venture capital firms right now that are really investing in new space, and in what kind of areas? I mean, of course, the spectrum is broader, but I'm just trying to provide you some samples. And then a little bit about that data science, new space, in particular with two trends that we see there: internet from space and Earth observation. And then some things going beyond, like space manufacturing, and what's the timeline there? What are the challenges? And what I'll try to wrap up with what I like to call the space Earth confluence, because we really see right now the mix of two separate worlds, right? All the space exploration that was government driven was a world in itself, and whatever was going on terrestrially was developing itself. But now we see more and more the confluence of these worlds emerging in many different industries. So there's no way I can highlight that in the 1 hour, but I'll try to give you a good flavor of that. So in terms of the new space landscape, like I said before, I don't have a pointer, but traditionally, if you look at investments, the strategic investments in technology supporting space exploration have gone into launchers, big satellites, operations of these satellites, some ground segment, and then derived services. And this used to be the value chain, right, where the government, it was a government funded, government owned, government operated, right? The government was the only customer of its own investments. And we do see that development and merging of what's going on in space with miniaturization in a lot of different areas: semiconductors, optics, the world of photonics that emerges, machine learning, AI, and additive manufacturing, right? And so this unprecedented diversification and growth capabilities, we see them reflected in lowering the barriers in accessing and utilization of space. Of course, primarily, especially in the US, and I'll try to focus on the US, but whatever, because NASA, of course, is the biggest public, it's the only public space agency, but it has the biggest budget out of all the space agencies in the world. And so, of course, wherever NASA invests drives, the development of technologies. And when I used to work at NASA in supporting these different areas of strategic investment, there were at least 6 drivers that I want you to take, because it helps you think of how the thinking is within NASA, right? So one is definitely the near Earth, which is low Earth orbit, right? Expand utilization of near Earth space, then develop efficient and safe transportation through space, increase access to planetary surfaces, enable humans to live and explore on planetary surfaces, enable the next generation of science missions. So this is really deep space exploration. It could be any planet, it could be the solar, it could be the sun or beyond. And then of course, also make sure that there's growth and utilization of the US, both industrial and academic base. So of course, these strategic trust or strategic investments go and feed, the development of technologies traditionally for space. So for example, in near Earth space expansion, it can range from laser communication to materials, right? Nanocomposites, proximity operations, different kind of optical communications and sensors, integrated solar arrays, right? So this is just to give you a flavor. Transportations through space, technologies that are of interest there or that are prioritized, green propellant, other kinds, so solar electric propulsion, cryogenic technologies, nuclear thermal propulsion, etc. So this just to give you, some flavors. And of course, NASA works with a lot of partners in this field. Now, what we also see happening is not only the diversification of investments in new space, but of course, as we see more public-private partnerships forming, the policies and regulation need to come in and support this kind of development so that the commercial segment can grow, right? And so what I'm trying to highlight here on the left is a couple, so it's a timeline with that reflects, a kind of policies that have come into place 2003 onwards. From remote sensing, which means you put a sensor on a satellite that detects some kind of variable terrestrially, to GPS, global positioning system, space traffic management, to the more recent commercial regulation, the Space Policy Directive, and space transportation that the policy addresses the national space transportation policy. Now, there's of course always, as these things expand, there's always issues. And so, for example, export control, it's always one issue that one need to be aware when we work related to space technology or new space. But what we see developing is also the space situational awareness, space traffic management, debris control, and the sharing of the radio frequency spectrum, which has become lately, an intense area of debate. So again, if you look at the decades, 1990 to 2000, 2000 to 2010 to 2015, 2015 to 2020, and it keeps expanding. All these investments from the government side have been synergistic with the commercial effort in lowering barriers. And when I say lowering barriers, it's literally accessing space. So during the shuttle program, the capabilities of going into space, right, were literally, and of course, if you look at the z-axis, you can access space through parabolic flights, so that you have a parabola, and then on top of the parabola, you have some microgravitational, like about 20 seconds of microgravity, where you can do some experiments in a reduced gravitational environment. You can go suborbital or you can go orbital. And literally there was one capability in each of this area that was, again, government owned, government operated. So of course, the price, the variable that we talk about is the price of a pound to orbit, taking a pound from the gravitational well into orbit, right? So that used to be, it's very unclear, but it used to be $30,000 per pound or more. So of course you can't commercialize, you cannot, close your business line with such a number. But not only that, but the frequency of going up and down. So even if you wanted to put a payload, it wasn't, much, maybe, 1-2 a year, right? So what we see, specifically through the breakthroughs that and the fast-paced execution by SpaceX, because they were really the pioneers in this area, is a drop in price and increase in frequency. And what that translates to is a reduced price per pound to orbit or per kilogram to LEO, $5,000 approximately. I mean, of course, there's a variation and so on. I'm just trying to give you a reference point. There's a lot of debate in terms of what exactly that number is, but also increased frequency. So you can have now much more frequent access, but also a much more diversified spectrum of providers of flights into orbit. And with, again, the continuous expansion and diversification of this value chain, we're looking at 1,500, and some people are even talking about $100 per pound to orbit and monthly flights. And so what that means is literally the democratization of accessing space. And we do see that in new space, which is why we talk about new space as a market, and we can even assign a dollar value for this market. Not only that, so this is, again, removing access barriers, but also we're talking about miniaturized platforms. And in this case, the platform of that has really picked up is really what we call the small satellites. And I'm just showing you the main component of the building blocks of a small satellite. And you can think of it as these small satellites as transmitting in one of these bands, the C band, the KU or the KA band. So they can beam back to Earth information, or you can put on a satellite synthetic aperture radar or a hyperspectral camera, and the recording of those images is again beamed down to Earth in one form or another. And so that's again the early development of merging cheap access to space, frequent access to space with a miniaturized platform that now can become versatile in terms of the functionalities that you can extract off of it. And of course, these small satellites, in order to operate, they need to connect with the terrestrial infrastructure. So as you see that not only we see developing high capacity satellite constellation, but also the need now for inter-satellite communication. And I'll explain how that parameter space works, as well as a lot of automation in electronically steered antennas, because traditionally you had just a few big antennas here and there, but now you really want to have the mobility and the coverage. And so that means a lot of investment go into this kind of steered flat miniaturized antenna themselves. So this is an example of Lux Capital investing in Kymeta, and this was the world's first electronically steered flat panel satellite terminal that you can put on a car or you can put on a boat, and then you can ensure satellite connectivity. So my point here is that because of this, you see a whole supply chain growing and developing, and we're talking here about emerging markets, and this is really important for emerging markets versus traditionally established markets, right? So we really see the development from one capability or one company that really has to split that functionality and share it with as the value chain develops. So I'm just highlighting here a couple of elements in the supply chain. So the ecosystem, you could say that it consists of the communication system, the satellite manufacturers, and the operators and users. And again, this one are a couple of examples that are traditionally there. So by 2015, this has become, again, not just a noise, but it really has become something transformative, to the extent that a lot of the market reports have started to pay attention to this. This is just one highlight of the Goldman Sachs space report that says, okay, space launches cost 11 times less than in 2010, so that's in 5 years, plus the satellite cost 100 times less to manufacture than in 2010, right? So now you see a factor of 10 and a factor of 100 decrease in price. And so the bottleneck at that time has then become that there's not enough launches. So now we see a lot of small companies and startups, again, providing alternatives to launching satellites into space. Overall, just to give you a sense of the value of the global space economy, so this one really shows the split between the government and the government and the satellite industry. And so we see that the satellite industry is growing. Not only that, but between even 2016 and 2019, the number of countries in the world investing in space, it's at a steady increase. So we're now talking close to 90 countries in 2019 that especially we see a lot of developments, for example, in Africa and in Asia, where even the smallest country in Asia, in Africa, they have their own satellite instead of going through the major providers that existed before. And like I said, now zooming into the global satellite industry, as I said before, you can see reflected here the different segments, the launch industry, the satellite services, the ground suppliers and equipment, and the satellite manufacturing themselves. And zooming even more into this, the satellite services segment, it's interesting because what didn't exist before is this Earth observation segment. And I'll talk about it, right? Where you capture data, images from space, and then how do you then use that for a variety of applications, from agriculture, resources, urban development, etc. So at a glance, and again, this is a collection of many different sources, the overall number for the global space economy is somewhere around $360–400 billion, with all these splits that I was mentioning about, from government spending to the different sectors, including the satellites, and within the satellite, the services, and if you can go and split that. So just to have you leave with a couple of ideas here. One is the satellite platform. The de facto size for that is what we call a 1U, and a 1U is literally 10 by 10 by 10 centimeters. But you can go and multiply 2Us, 3Us, 4Us. So just if you ever come across this notion, then okay, in new space, this is one of the standards that people talk about. What I mentioned before is there's two main areas in new space, or at least in this market segment. One is the satellite connectivity from space with the multiple constellations that are forming, and the other one is the Earth observation. And then, of course, the underlying necessary infrastructure is launch services. So I mentioned that. In terms of the space startup support, so this is literally private investment. Just to give you an idea, between 2009 and 2018, there was a total of $18 billion of private investments. And to date, approximately, there's about 534 VC funds that are investing in space, just to give you, again, an idea of the numbers. So when we talk about this new space value chain developing, we see, for example, sometimes bigger players in the traditional aerospace that reinvent themselves. So and also purchase different other companies. So I'm talking about consolidation, and I'll give you an example of Maxar Technologies. You can see simplification, right? The small sats has simplified a lot of the operational complexity and so on. We can see growth and expansion. So for example, SpaceX originally started as a launch provider for space, but as they're establishing themselves more and more as a launch provider, they also need the infrastructure as the ocean fleet, right? So they picked up the SpaceX ocean fleet, and they're also now a launcher of their own satellite constellation that's called Starlink. We can also see some what I call coordination the Starlink Tesla example that I'll talk, acceleration due to these launchers, and also streamlining of services. So I'll talk a little bit about FedEx. So Maxar, for example, yeah, sorry, this covers. Traditionally, I would say Space System Loral for us who are based here in Silicon Valley used to be a geo satellite manufacturer. So recently, the Maxar has gone and purchased and put together, these 4 companies. One with the space system segment, in the space system segment, Space System Rural and MBA. The imagery segment, they purchased Digital Globe. And then in the service segment, Radiant Solutions, which is really taking the machine learning, AI, and data analytics at scale. But you see, they're trying to have in-house all the main elements that provides this diversified business mix. And also, it arms them with a robust pipeline of large new business opportunities. So they sensed the strong market tailwinds, and they were able to reinvent themselves while capitalizing on their technology investments in the past and the momentum that exists right now. So if you really are curious, what are their capabilities? That again covers communication satellite, remote sensing satellites, radar satellites, satellite ground stations, a lot of robotics capabilities, in space robotics, as well as the satellite components and payloads, and of course their defense system segment. FedEx is really interesting. I mean, probably you all know about it, that it's reinvented itself ever since its formation in 1971. It moved the headquarters to Memphis, and then it expanded by also purchasing the acquiring Caliper and then Kinko's, and continue to acquire smaller companies to expand their international services. But in terms of new space, or what, let's say, this landscape cares about, in 2014 they stood with a small investment, what they call Space Desk. So they had a 24/7 number where you could call. It was a one-stop shop for the space industry customers, because what they said is, well, we have the knowledge of transporting special packages. We also have the capabilities of transporting special packages like cryogenic, or so they decided, okay, we can put all that know-how internally that we have internally, the shipping information, geolocation, tracking, and packaging, and see what kind of responses we get. So that led it to 2015 to this internal business part, that's separate business line that's called FedEx Space Solutions. And so it's literally ever since is capitalizing on this burgeoning commercial space industry. So that's another model. The SpaceX fleet, like I said, this one is literally tracking all the SpaceX that's the SpaceX owned assets that are not going to space. And so, like it says, like it's listing here. So I don't know how much but one of the very innovative ways that Elon has brought into this into the space launch services is the fact that he's recovering. So a rocket has several stages, and he's recovering the first stage. And in order to recover that first stage, he literally landed that on a platform on the water, right? So that's what the that's the origin of this SpaceX fleet. That's been growing, right? Because you now necessitate a lot of infrastructure in order to track that, bring it back to to the continent and so on, right? So it's land recover and reuse. This was interesting and analysis. So with the fact that, of course, right, if you have a launch service, you can launch your own satellite. So that became another internal development within SpaceX. So not only they're manufacturing their own mini satellites, but of course they're giving themselves a good discount in launching these satellite constellations. But the interesting thing is, in April 2018, Tesla applied for a license for a particular technology that had to do with the communication device transmitter. And there have been ever since speculations, I haven't worked within Tesla to confirm this or whatever, but that Tesla vehicles will be outfitted with receptors that would communicate with these Starlink satellites. So the whole idea would be that now you have established this receptor-transceptor, this receiver transmitter unique relationship, and that could turn Tesla vehicles into local hotspots for in-car Wi-Fi, right? So I think this becomes very interesting in how satellite constellations connect with the IoT, and will maybe change and disrupt to some extent the way we traditionally think of Wi-Fi or internet providers. Okay, so talking about private investments, Space Angels is one association of investors, and I just wanted to give you, a glimpse into the kind of startups that they've been funding, in particular to data processing or more software side. I would highlight Planet, Picteria, and Skywatch, but I would also mention ICE-I. ICE-I is it's one of the highest resolution synthetic aperture radar that you can put on a satellite platform. So it's providing high resolution imagery. Leo Labs spun out of SRI. It's tracking orbital debris in orbit. So there's a variety of investments. Lux Capital, that's another VC fund here. They normally invest, technologies that are out there. In terms of their new space portfolio, I would mention again Planet. Planet was one of the earlier companies that have a suite of satellites in space that put camera on the satellite and recorded the first images. So they have the largest database of images that are able to go in and assess not only what's going on right now at a certain location, but they can go back and look at the history of that spot, right? So, and extract the information that's relevant to a certain application. So Kymeta, like I mentioned, that's flat panel antenna. Orbital Insight, again, analyzing satellite and other remote aerial imagery. Relativity, this is actually Relativity Space is related to another way of launching in space. Airbus Ventures, Leo Labs, like I mentioned before, are and Spin Launch are two of the companies in their new space portfolio, but they do fund a lot of other areas such as autonomy and connectivity, and especially in connectivity, I wanted to highlight a couple of companies there that are more focused on AI, machine learning, data analytics, and so on. And then there's Seraphim Capital Portfolio. Their investments are primarily on UAV, satellites, and drones. And for example, let me see, QuadSat. Yeah, QuadSat is the autonomous drone-enabled satellite antenna calibration. Altitude Angel is also drone related. So you see, I mean, new space now starts to merge with everything that's above the surface of the earth, right? So we do start seeing this mix between what's traditionally out there in space and, going and populating more of the Z axis. And, again, because I thought that I'm coming here and I'm talking to people who are more interested in data science. JetBlue Ventures, in their portfolio, they do have a lot of companies that are looking into improving the way people travel. So whether it's hospitality, whether it's connecting from the airport to a destination once you arrive at a certain place, I think there's a lot of opportunities for data and analyzing data and extracting good data, good value out of this data. Okay, so in terms of data science, so this I put something together here. Can you actually see these things? Because I see them really well on my screen, but this is very blurry, unfortunately. Yeah. Well, my point is, yeah. Yes, you can get it, and I think they're also recording. So yeah, you can look to this. Okay. Okay. Not touching on that. But what I thought, and this is a report that I haven't done myself, but I really thought that in the literature it was really explaining very nicely how did we how this whole concept from data analysis and statistics and mathematics and different means that existed earlier, right? So it's literally, if you follow these 1, 2, 3, 4, 5 lines, the first one is computer science, then data technology, visualization, mathematics, and statistics. And you see how these lines come to merge at this point in time into what we call big data and analytics. So I really thought that that was very interesting. And of course, it mentions different key developments on this timeline that have really played significant contributions in moving the field forward. So, once you have these kind of skills in your pocket, basically in your portfolio, you can apply them. And the reason I selected here, or how traditionally people use this kind of skills in telecom, is because this skill set now becomes a transferable skill set to satellite operation, satellite constellations, right? Because indirectly, you're still looking kind of the same thing. So for example, predictive analytic, you want to have faster, better data-driven decisions, right? You want to know who your customers are and what are their preferences and how you look at customer segmentation. You want to look at fraud detection. You want to look at network management and optimization, anomaly detection, right? If there's some malfunction on your satellite, right? Or on your terrestrial ground segment. Price optimization, infrastructure monitoring, right? So these are things that currently exist where a variety of telecom companies